Good morning, weather weenies. It is Thursday, April 25th, and it got cold last night, like cold. Let's talk a little bit about last night's cold, and it's going to get cold again tonight. And I want to tell you how it's different, and let's talk about some very detailed thermodynamics that you're going to understand. Let's put the events into perspective. This is how cold it got last night, and this is how cold it's forecast to get tonight. So, not quite as cold for most locations. There could be one exception. Oh, and real quick for comparison's sake, this is the HRRR showing what it was forecast to be like early this morning and what it's going to look like the morning of Friday, April 26th. See the differences in the forecast models? Like we've talked about that. It's another video for another time. Back to temperature inversions. So in our atmosphere, for several different reasons, it's warmer near the surface, it's warmest near the ground, and the temperature decreases as you go up. There's two primary drivers of this. One, the sun shines down on the land, the grass, the pavement, warms things up. And as that leaves that surface, that heat dissipates. The second, and the main reason why it cools as you go up in the atmosphere, is because you get a decrease in pressure. And that you also, with that correlates, you get a decrease in temperature. And so as you go up in the atmosphere and the atmosphere gets less, the temperature drops. There are times when that is not the case, and these are temperature inversions. If you were to look at a weather balloon, this is the freezing line. So as we go up in the atmosphere, you can actually see here, the temperature got warmer here before it finally decided to decrease like it typically does. That temperature inversion is the thing that will give you those really cold nights, like those really, really cold nights. If you live in like a lower elevation or you live in a valley, this is the thing. So what happens with the temperature inversion is, say you live in a valley right here. And what happens is if it gets still, if you don't have wind, which is like a big old whisk for the air, if you don't have that in this valley, the pressure is going to be generally about the same. It doesn't change too terribly much. And so what happens is the cold air pools, cold air sinks, and the warm air rises. And so in these lower valleys, if it can get very, very still, the temperature can plummet. What's especially neat is if you are in that valley and you're between the mountains and say the ambient temperature, the air temperature was colder up top, as you lose the sun and as those temperatures start to fall, that air will just sink and pool and will continue to cool as it sits down in that valley, and all the warm air is going to try to go up and escape above that. So if you live in low-lying areas and you've ever noticed like, holy cow, it can get really cold where I am, it's because of this temperature inversion. Now, last night's and this morning's cold for Thursday, April 25th. It was very windy in a lot of places. The winds were super high, so we didn't get this radiational cooling. We didn't get this decoupling. We didn't have this inversion in place. Last night's wind kept things mixed. It didn't allow for that calm and that stillness to allow temperatures to kind of move around and do what they want to do. Tonight, the evening of Thursday, April 25th, going into Friday, I think I said Tuesday, Friday the 26th. Now this is going to be a different story. The cold front came through, the cool air is here. It's going to be nice today. It's actually going to warm up a little bit. But then tonight, it's going to get very, very still. It's going to be incredibly calm. And what you're going to get is this radiational cooling. So tonight, the places that really need to be aware of the frosts and freeze, you are going to get some at higher elevations as well, just because like if you're up in the whites or what have you. But otherwise, really low-lying areas have the potential to see colder tonight than they did last night. Most of us will notice that it's actually a little bit warmer, that it's not going to be as cold. But those few line places, if you are in like the Connecticut River Valley, for example, you know this. You already know this. You live there. It's tonight is going to, could potentially be the colder night for you than last night. The wind plays a big factor in that, but the other thing that plays a huge, huge factor is actually cloud cover. Clouds act just like a blanket. So even if it gets really, really still and calm, but we have a cloud layer in place, it actually helps to insulate everything and doesn't let this change happen. It doesn't let that warm air escape. Tonight, however, is going to be one of those calm, clear, crisp nights, and that's what's going to allow that temperature to really drop. And the forecast discussion says it here too. Mainly clear skies will persist tonight. Winds quickly decreasing this evening with the loss of daytime heating mixing. This will set the stage likely for excellent radiational cooling. This is everything that we are talking about. Despite the relatively short nights of late April, as a result, for the forecast guidance lows, they push down what the forecast said for like a few additional degrees for some of these typical spots. This places lows into the teens across normally colder interior valley locations with 20s in most other locations. And the third part of this really is that humidity. Because the humidity is so low and has been so low, it's why the fire weather like danger has been real high as well. It's just kind of setting the perfect stage. I can see it coming now. So last night was cold because the cold front came through, but it stayed windy and didn't allow these inversions to come into place, and you get this radiational cooling. Tonight, though, with no clouds, calm winds, and low relative humidity, I can't wait to hear from some of you in low-lying areas what your overnight low was. So one more night of keeping those plants covered, not putting stuff outside. Just wait, hold tight. It's going to be real interesting to see what happens tonight. But now you know why. This is a major thermodynamic process. And now you get it.